A very good morning to one and all present here, and thank you for joining us at 3 days international conference on computational techniques and intelligent machines in collaboration with IEEE Computer Society, Waterloo Section Canada, MSEST Morocco, SIRG Exhibit. It gives me an immense pleasure to welcome all the participants today for 3 days international conference ICC TIM 2020. I welcome all the eminent speaker and guests from all over the world to share their knowledge and vast experience with this community. So we have entered in the third and last day of the conference, and this is the last session of this conference. And the theme of this session is advancement in sustainable engineering and automation and its applications. This session is chaired by eminent Professor Ihtiram Raja Khan. This session is co-chaired by Professor Dr. Manish Bansal. For the keynote speaker, we have Professor Arun Raj, and we have, for the invited talk, we have Professor Ihtiram Raja Khan. In this session, more than 15 papers will be presented by different researcher and faculty from the different part of the country. So now, before starting this session, I would like to take the permission from the chairperson, Professor Dr. Ihtiram Raja Khan, to start this session.
Yes, sir. Gurpreet, sir, you can please start the session.
Thank you, sir. Thank you very much. So first, for the keynote speech, I would like to invite Professor Ihtiram Raja Khan. But before inviting, I would like to introduce about Dr. Ihtiram Raja Khan. Dr. Ihtiram Raja Khan is currently working as a professor at School of Engineering Sciences and Technology at Jamia Hamdard, New Delhi. He has about 25 years experience of teaching and research. His research area is artificial intelligence, machine learning, soft computing, and big data analytics. He has published numerous research papers in peer-reviewed international journals in this area. He has also authored 15 plus books in this area. Dr. Khan has given expert talks in many FDPs and refresher courses. So now I would like to invite for the introductory speech to Dr. Khan.
Yeah, thank
So
you.
now handing over the mic.
Thank you,
Dr.
Mukesh, sir. Thank you so much. Yeah, I thought Professor Arun Raj would be taking it first. So, are we not having his speech today?
Sir, actually, sir has not joined this meeting.
Okay. So just give me a minute. I'm just uploading my presentation. Okay, and yeah, we are starting in a minute time. Thank you so much, Mukesh, sir. Is my screen visible and am I audible, Mukesh, sir?
Yes, sir. Yes, sir. Screen is visible completely fine, sir. And your voice is also audible.
Okay, so welcome everyone. I welcome all the participants and all the dignitaries who are present here for this final session. This is session 13. It's been wonderful 3 days of the conference. I've been following all the 3 days. And I would request the audience to please switch off their mics unless and until they have to ask any question or they have to interact, because there would be disturbance, a lot of disturbance behind the screen if your mics and all are on. So please put the mics on off and we'll be interacting, and I'm with you for another 1.5, 2 hours for the session also, complete session, where we'll be having our questions also. And yesterday I was in one of the sessions where there were wonderful research papers, wonderful presentations, and we're really happy to see the kind of stuff that is coming. And there are a few cameras available which are there on the screen. Please don't lie down on the bed, and this is a conference. Please maintain the dignity of being a conference. I request Mr. Manish to please either switch off the camera. It would be better if you switch off the camera and listen. Manish sir? Mukesh sir?
Yes, sir. I am calling to Manish, sir. Could you?
ये मनीष को आप वो कर दीजिए,
Yes, yes.
डिसेबल कर दीजिए जी, कैमरा डिसेबल कर
Sir, actually, the right of disabling. Yeah.
yeah, so that was the problem there.
सर आपके पास ही राइट्स हैं सभी, आपको होस्ट बनाया हुआ है.
अच्छा अच्छा, I can do it. Okay,
yeah.
So just a moment. Yes, so I'm starting the presentation. I'm Dr. Ehtaram Raza Khan. I represent Jamia Hamdard. It's one of the premier institutes, premier universities in Delhi, and it has been awarded the tag of Center of Eminence by MHRD, Government of India. Recently, there were 7 or 8 institutes awarded this tag, Center of Eminence. So we are a wonderful university doing wonderful research work, and would love to collaborate with your colleges and with all the researchers available here. You can always contact us for any kind of help that you have. So I'm starting here. So the topic of my talk is from the start to the present: how successful have we been and the road ahead. So this is about software development, about software technology, how we are moving together. I'll keep my session very simple. Everyone should understand, everyone should be, for last 2 or 3 days, you have been witnessing a lot on big data, IoT, on AI, machine learning, the research papers, the presentations and all. So I thought instead of giving everything on the research and presentations and all, which is your task right now, I'll be taking you to the journey of software development, how we have been in the start and how we are moving to the future. So it is how successful we have been and the road ahead. Special thanks to ICC ITM 2020 for giving me the opportunity. Special thanks to Professor Meher Chand, HOD. So if you look at the screen, the first sentence that you read in red color: software engineers have the power to create great solutions, but the best software to solve the least important problem is of no use. So if you go by this line, software engineers have the power to create greatest solutions. We have created the greatest of solutions you can see right now. The driverless cars you're seeing the AI-based systems, you are talking Alexa and all. If you look at that, you're just taking out some words from your mouth and the system is understanding, which is natural language processing. And so software engineers are giving you the best of solutions, but the best software to solve the least important problem is of no use. So let us devote this software engineering paradigms. Let us involve these methodologies of software engineering for great softwares, not for small tasks that we are doing. Let us take it to COVID. We can have a wonderful research into COVID and all, which we can give the solution. Unfortunately, so far, we haven't been able to match what was expected of software engineers, of software developers. That's why we are still struggling to fight COVID. So let us now move ahead. The journey of software engineering has been a long one. It started with the word software crisis, which was a term used when the softwares failed and were unproductive and missed the schedules. I'm talking about the time 1970s and 1980s. So if you remember in 1970s and 1980s, it was only C, there was COBOL, Pascal, C, and then we had the initial start with DBase, database. So the softwares that continuously failing were unproductive and missed the schedules. You were asked to make the software in 6 months and you were just unable to fulfill the schedules and all. So computer languages used for software development at that point of time were Algol, COBOL, Fortran, Pascal, and all. So it was NATO Science Committee, which sponsored two conferences in which software engineering term was coined. So it was in late 70s that they came up. So if we define software engineering as concerned with theories, methods, and tools which are needed to develop high quality complex software in a cost-effective way. And the last line is important, on a predictable schedule. So you have to do it on a predictable schedule, which means that you have to, if the client is saying, I need the software in 6 months, in a year, you have to complete by that time. So I'll be dealing with a very important term just after 5 or 10 minutes. I'll be dealing with a very important term, which most of you must have been listening, and the word is agile computing. So that's where we have moved into from the conventional software development to agile computing. So let me take you to the next one. This is another journey. This is the same journey that we have been discussing. So the journey of our programming languages has been in this order. We started with C, 1972, C++, 1983, Python, 1989, Visual Basic came up, then JavaScript, C#, VB.NET, and our journey progressed. So from small softwares, monolithic softwares, one big software, one big code, we have moved towards the modular systems, where we have modules, we have functions, and we have, let's say, software is made up of many modules. So if you look at the third paragraph, from the transaction processing system, TPS, we move towards MIS. And from MIS, we moved on towards the decision support systems, where DSS worked on the higher level of management. If you look at the management hierarchy, it is the internal, the middle level, the lower level, and the higher level. So these decision support systems, they were working at the higher level of management, which is the executive class. So ERP and intelligent knowledge-based systems have become the next buzzword. So if you look at the topics right now, if you look at the conference topic also, intelligent machines, intelligent systems. So that's where intelligent knowledge-based systems are becoming popular now. We are working on them, and luckily enough, we have so much resources now that we can develop them at our choice. When we started researching in 1990s, I was doing my MCA. So when we were doing it, we had very little options. Like we were having only Lisp, we were having Prolog for artificial intelligence. So now we have Python. You can get along with Colab using Python. You can have R. There are so many chances now that we can maintain the system. So our journey began with monolithic software. Mono means one. That means we were designing one big software. And if there is some bug anywhere in the code, you have to design, you have to recode the entire software again. You have to code the entire program. So one big program which was difficult to code and equally difficult to debug if something went wrong. And the same was true for maintenance. So if all of you must be knowing that there are three types of maintenance: the corrective, perfective, adaptive. So the maintenance also was difficult for monolithic softwares. So if it now comes the presentation, I've divided into two parts. This is part one, where modular systems eliminated these problems and we started getting quality software products. Quality in terms of correctness, reliability, performance, usability, maintainability, reusability, and portability. So once we started having the modular systems with the coming up of C, C++, Java, we started to make modular systems, and our softwares now were of quality. And then two important words, reusability and portability. You can reuse the code again and again. You have made it for client number one. Now client number two wants the same system, so same banking system. You can code in lesser time because you can reuse the code that you have previously made. Portability, anywhere in this world, you take your software and the software doesn't need changes. So our initial strategy was always the waterfall model. You all must have heard about this term. There are four models in software engineering: waterfall model, prototype model, iterative enhancement, and the spiral model. So initially they started with a waterfall model where in the green box you see on the screen, it is plan everything out. You have to plan everything. The client comes up to you, I want a software from you, from your company. The client will give you the requirements. You will jot down the requirements. You'll note all the requirements. And then you ask the client, okay, I have noted all the requirements. I'll make the system for you. So if you look at the last para, let's take the example of waterfall model where all requirements have to be known in advance. So the client will give you all the requirements in advance. The problem lies with the communication gap between the developers and the stakeholders. So now 6 months, after 6 months, the developer comes up with your product. So this is the product you wanted. And when you see the system, you say, there are lots of loopholes. There are lots of problems with the system. Now the problem has been the communication gap. So 6 months communication gap in software development or 3 months communication gap is always a very big gap. So now if you dissect this waterfall model, this waterfall model works like this. You collect the requirements, you design, you implement, and then you deploy it on the client side. This kind of development will take a long time. And what would happen if the same product has been released by some other company? So 6 months is a long period, 1 year is a long period. And what if the other companies have come up with the same product? That's been happening with the software that we are looking at. The mobiles, if you see, one company launches a mobile, another company launches within a week the same kind of software with the same phone, with the same features, and they come up in the market. So that is the problem with the waterfall model as we were taking. So if you look at this last line, this is important. Expectations are never the same as reality. So we should change plan number one. So this is important part of my presentation. Expectations are never the same as reality. So we should change plan number one. We should move to another plan. Now, let me take you to another plan. This is a strategy number two. And this is where my talk has to be moving. Now, if you look at the green box, just look into this green box and you find you still plan, what with constant change in mind. Keep on planning, but with constant change in mind. So there were 17 wise men who sat together and came up with a new concept called agile computing. So they came up with the word agile and they had a meeting. They were talking about the problems that the software industry was facing, now what to do. And I just categorize also where we are using agile. Netflix, Microsoft, Amazon, and everyone, they are using agile computing. That's because of the concepts that I'm going to teach you today. So for being agile, we have to look at these steps to do things little by little. So they will be doing the things in chunks, doing small bits. They are not going to wait for 6 months to develop the entire software and come to the client. They'll do small things. They will accept the change. They will accept the change. They will evaluate constantly. Evaluating constantly means they would be having regular meetings that the team, the agile team would be having the meeting along with the clients also, and they will adapt according to the situation. So whatever the situation is, they will adapt. Now, this is going to give you a lot of insight. Agile technology has touched all of us: Amazon, Netflix, Facebook, Google, Adobe, and many more. They're all making use of agile computing. Have you ever seen Netflix comes up with something and very soon your Prime comes up with another features more than those features which are given by the Netflix? That is because such is the competition. They will just see what the competitor is doing and they'll change their basic layout. So that is where Agile is coming. Agile would mean that keep a constant watch on the market, keep a constant watch on the competitors, and then whatever changes they're making, just change, adapt yourself, change yourself according to that scenario. So being agile would mean release software in chunks, get the feedback from the stakeholders. Now that's where it is important. You're getting the feedback from the stakeholders, which are the clients for whom you're making the software, and your board team is there, your personal team, company team is there, and you're getting the feedback from them. How is the software? How is it working according to the market? How will it go into the market, and how will it give us the profits? And then you see re-released according to the customer satisfaction. So you see Netflix has done something today. There's Prime and all, Amazon and all, they will come up with different plans and they will re-release their product the very next day, or even surprisingly, it is even in 6 hours time or 3 hours time that they will come up with the change of the product, change of the basic layout of how the website is coming, how their ads are coming, how their serials and all, they are coming up. So I'll again come back to this. If you read this red paragraph, Instagram was initially location tracking application, but getting the feedback, it was adapted to what Instagram we know now. So initially it was location tracking application, but now if we see Insta, we are using Insta for all kind of photos, all kind of videos. We are even using it for chatting and all. So YouTube was dating application and Twitter was a music sharing application, but they were released later with different purposes because they saw what the market wanted from them, and they re-released the product according to the customer satisfaction, what the customers want from you, what the users want from you. So the benefits of being agile would be productivity, quality, customer service, and satisfaction. So these are the benefits of agile computing. So let me explain it, how we do it, how we are doing it in companies. Almost all the CMM level 5 companies, which you know, capability maturity model companies, which are level 5 companies, they're doing it the agile way now. Either it's TCS or Ericson or it's your Birla, every company, your Reliance, your Geo, and every company that you're talking about, they're making use of agile computing. Netflix and all we have already talked about. So how do it the agile way? Break a project into 2-week iterations. So they are focusing basically on 2 weeks, 15 days work. They're dividing it into chunks. Scrum, which is in bracket, it's agile team. So Scrum will work together. Your agile team is called Scrum. Scrum will work together to achieve a common goal. They will work for 15 days together to achieve the goal. Keep a 2-week delivery for the team. Scrum coach, Scrum master will monitor the progress. They are sitting in a team, they're working. The team will meet for 15 minutes regularly. They'll meet, discuss, and adapt. And they are, for these 15 days, the team is constantly meeting for 15 minutes regularly. They'll meet, discuss, and they'll adapt to the changes that the market wants from you. And after 2 weeks, the feedback from the product owners and its stakeholders is taken, and continuous delivery and customer satisfaction is looked into. You release it on the internet, you release it on the website, and instantly you get the feedback from the customers and how satisfied the customers are. So as the technology is moving at a fast pace, we have never seen this kind of a pace from the technology. You do a technology today, and after 2 months, you find another technology is overtaking it, and we have to even go through that technology. So computer science has been one of the most difficult fields to study. Initially, we thought we are master of C, C++, we can do anything. But right now, we are constantly changing. So I did my MCA in 93, but then every other day we are changing according to the scenario. We are studying Python, we are studying R, we are studying blockchain, we are studying everything that is coming up, big data and all we are studying. So we have to study with our research scholars over there. They're working tremendously for us on big projects. We have IoT projects under me. My research scholars are working on IoT projects. They're working on blockchains. They're working on smart agriculture. So it's been something where we see that the technology is moving at a very fast rate and we have to adapt. So agile is the way of leading that fight. So agile would be to adapt to the next level, groom the requirements. You have to set the requirements right. iterate the project. You have to iterate it. You have to make it chunks. You have to move in iteration, then launch and learn from the experiences. And then you should have an empowered team, which is a flexible team. So we have moved from the standalone systems. Mind it, when I started coding, we had black systems, we had VEX systems. You must all have heard the names of mainframes. We worked on the mainframes. It was VEX and Alpha, and the screens were all black, and we only had Pascal and Fortran in it. So just remember the kind of programming efforts that we were doing to make softwares in Fortran and in Pascal. And then when C came up, we were so happy we have something to develop the softwares in modules, and we started working on C. So it was all black and white that we were studying. We got the first colored system in our lab in 1996. We got the first time we got a colored system to work on Windows. And I studied in Aligarh Muslim University, which is a wonderful central university. And we used to have a booking of only 15 to 20 minutes. And we were working on that. And in those 15 and 20 minutes that we got from the system, we were constantly coding, we were constantly working, and we were putting in all the hard work. So the journey has been a long one, and it has been a very tedious one. But now you're lucky enough, the researchers, the teachers, the researchers, the experts in the market, we are lucky that we have everything at our disposal. One fine day you would find, if you just search on the internet, Google Colab, you can code for the entire Python, you can code for R, you can code for data science in Colab with minimum of effort. So you don't even have to download all the libraries that we have been doing in Jupyter and all. You can just use the online Google Colab, and you can just work on your projects on that. So the things have become so easy now. The resources are there with us. The help is there. Our teachers and our guides are all there. So please work hard for this. Try and take the research to a new level. Try and develop something which is unique. So some of the topics of research in software engineering, which are going along on there on the screen. Software engineering, data analytics is very popular right now. Quality engineering is very important. Effects of agile teams on software productivity. Impact of team homogeneity on software quality. So there's so many. Cost estimation is there. So wonderful avenues to do research, to write research papers in software engineering. We are all doing it in big data. We are all doing it in artificial intelligence, machine learning, face recognition. We are doing it. So if you want to move us slightly away from that field and go into software engineering, this is a wonderful area to work on. Yeah, Mukesh sir, any questions? Please leave it to the audience.
Thank you, sir. Thank you very much for this wonderful talk. From the participants, if there is any question, then you can ask.
Else we will start with the session.
Yeah, definitely, sir. If there is any question, then you can.
You can even type in the chat box if you have any question. We'll
sure.
give the answer later. You can type in the chat box. Some of you are not comfortable speaking, so you can always type in the chat box. We are waiting. So Mukesh sir, we have lots of paper today. We can ask the participants to get ready in the meantime.
Yes, sir, definitely. So, sir, first I am telling the sequence to the participants in which sequence they will present the papers so that they can ready accordingly.
Yes.
So I am first telling first few sequence in which they will present their papers. So the first turn to present the paper will be by Aditya Raj, and the title of his paper is A Review on Cryptographic Approaches in Wireless Sensor Network. After that, the turn will be by Kamal Jyoti Talukdar, and the title of her paper is Modeling of Water Distillation Unit Operated by Solar Photovoltaic Modules. After that, the turn by Umed Tuba, and the title of his paper is A New Convergence of sequence of fuzzy star-shaped numbered dinner by LP Metric. After that, Mehtab Alam, and the title is IoT and AI for Smart and Sustainable Agriculture. After that, the turn will be by Rahul Kumar Meena, and the topic of his paper is effect of bracing system on multi-storied steel building. Then the turn will be by Shreya Arya, and the title of her paper is Blockchain Technology and its Transformations. And the other sequence will be shared in the chat section meanwhile.
Okay, sir.
So, for the first paper presentation, I am calling to first researcher, Mr. Aditya Raj, for his presentation. So, I am handing over the mic now to Mr. Aditya Raj. Meanwhile, if any delegate have any query, then they can type your question, your query in the chat section, so that later it can be answered.
Answered, yeah.
My voice is audible and my screen share is.
Yes. Hanji sir.
Okay. Good morning to all of you. My name is Aditya Kumar.
Good morning.
First of all, I would like to thank to Baba who gave me the golden opportunity to attend this conference. My topic is a review on crypto approach in wireless sensor network.
Yes, Aditya, move along. You're audible also, you're visible also. Yeah.
So in wireless sensor network, it can be defined as configured and infrastructure-less wireless network to monitor a physical or environmental condition such as vibration, motion, temperature, etc. And corporately pass their data through the network, the main location or a sink where the data can be observed and analyzed. Basically, language, we can say that a collection of sensing device that can communicate wirelessly. A wireless sensor network builds of node. Typically, a wireless sensor network contains hundreds or even thousands of sensor nodes, where each sensor node is connected to each other. The sensor nodes can be communicate among themselves using radio signals. A wireless sensor node is equipped with sensing and a computer device with receivers and power components. The individual node wireless sensor networks are resource constraints, and they have also a limited processing speeds, uh, communication bandwidth, and the storage capacity. Here the wireless sensor networks, like as we discussed earlier, there are hundreds or even thousands of sensor nodes, and this is the sync node, or we can say that the base station. User access and analyze data using the internet. So they are the various applications of the wireless sensor networks, like military application, environmental sensing, area monitoring, health application, application, industrial monitoring, and agricultural sector. So I would like to discuss like in military applications, the wireless sensor network is an integral of the military commands, control, and communication, and also a battlefield, etc. In environmental sensings, it is further classified the major areas, or we can say that the broad areas like air pollutant, fire forest monitoring, and the landslide detection, etc. In area monitoring, sensor detects the event being monitored, heat, pressure, and many more, etc. So the goals in the wireless sensor network are basically there are two types of goals as we discussed in the networks, like the primary goal and the secondary goals. The primary goals are following like data confidentiality, data authentication, data integrity, and the data. And the secondary goals are data freshness, self-organization, time synchronization, and secure localization. So I would like to discuss the primary goals, primary in the wireless sensor network. Like in data confidentiality, it ensures that only authorized senders, nodes, only nodes are able to access the content of the message. In data authentication, it ensures that the sender identity, like data sent from the correct source or not. Basically, it's verify the sender identity. And the third one is data integrity. Data integrity ensures that the data has not the tampered with the other users, or we can say the attackers. So providing the security in wireless network is the very challenging task. So here some few security schemes in the wireless sensor network: cryptographic approach, secure key management, secure routing, authentication, and the intrusion detection system. So as I am reviewing the cryptography approach, so I'm starting with the cryptographic approach. Uh, in wireless sensor network, here the continuously goes, they become vulnerable to attack, and hence they need the security mechanism. As the wireless sensor network faces major security deployment in remote areas. Uh, in cryptographic approach, even utilize the meat of the basic security requirements like confidentiality and integrity in the networks. The right selection of cryptograms are basically depends on three major components like time, memory, and security. In time, we can say that it ensures that it checks that the how much data to how much time to encrypt or decrypt the data. Coming to the memory, as we know that we have a very limited memory in the wireless sensor network. We must know that the how much memory consumptions is there. And security is also important. Like it also should meet the confidentiality and in message. Here the standard crypto systems. So we have two algorithm: encryption algorithm and decryption algorithm. So we have senders and receiver. So basically, sender sends the plain text. Sends the plain text to the encryption algorithm, and the encryption algorithm encrypt the plain text with the encryption key to the ciphertext. Uh, here the ciphertext, the attacker gain the access to the message, but they can't be able to gain access to the message. So receiver wants the original message. So receiver uses the decryption algorithm, the ciphertext into plain text using decryption key, and receiver get the original message which senders sends. There are basically two types of, there are mainly two types of cryptographic approach. Like the first one is symmetric, and the second one is asymmetric cryptography. So the symmetric cryptography, in symmetric cryptography, it is also known as the secret key cryptography. It uses a single secret key for both encryption and decryption. As we shown in the figure, the source and destination uses the same key to encrypt or decrypt the message. Symmetric key cryptography computationally faster than the asymmetric key cryptography, and the encryption complex. Symmetric
Aditya, please move quicker.
symmetric
Time
key.
would be getting over.
Yes, sir.
Yeah,
So,
please come to the main work. Yeah.
as we coming to the as we asymmetric cryptography, asymmetric cryptography is also known as the public key cryptography. So it uses two key named public key and private key for both data encryption and decryption, and it takes away the security risk from the attackers. Asymmetric key used in wireless sensor network. Basically, asymmetric key cryptography is provide better security than asymmetric key cryptography when the sensor nodes is too high. If about the symmetric key cryptography, it is uh, it is not to provide the better security when the sensor node is too high. It is capable to provide the in the few sensor nodes. Researcher also provide advanced public key cryptography like elliptic curve cryptography, identity-based cryptography, based cryptography, and hybrid cryptography. So basically, I deal with the elliptic cryptography like uh, in elliptic curve cryptography. It is very faster for the numbers of reasons like smaller key size, low CPU consumptions, and the low memory uses. ECC means elliptic curve provides number of benefits like increased in strength and performance. If we compare the elliptic curve, means if we compare the advanced public key cryptography and the normal public key cryptography, in advanced public key cryptography, we take the elliptic curve cryptography, and normal public traditional public key cryptography we choose the RSA. So ECC is much more beneficial to the RSA because
Aditya, please
in terms of
conclude. Aditya, please conclude.
okay. Yes. So, conclusion, in wireless technology is just upcoming technology, and security is the main concern in the wireless sensor network. So, providing in the wireless network, it is very challenging task. So wireless sensor network many constraints, as we know that the limited energy, processing capability, and the storage capacity has unreliable communications. So there are many ways to provide security. So I choose the cryptography approach for the sensor node is the fundamental to provide appropriate security. Thank you, sir.
Yeah, Aditya, have you worked on any system? Have you made any system, any simulation tool, or any? You worked on any simulation tool for this?
Yes, sir. Actually, this I worked on cryptographic approach
Hmm.
of the award of Master of Technology in Computer Science Engineering. So I used cryptography. In
This is
further
basically you're
elliptic
talking theoretically.
cryptography,
My question is, theoretically you're talking about it. Have you done anything practically also on this?
sir, I am working like to implement this thing.
In
It
which
also consume
platform would you implement this?
so basically I use MATLAB.
MATLAB, okay. So you are a student or you're a teacher
Yes, sir, I am a student. Sir, I am a
of,
student.
student
Uh,
of?
so I am a student of final year of the in Master of
Okay. Chalo, a lot you have to do on this, beta. Just take a few good research papers on this topic, go through them thoroughly, and then try and implement this. Even if you implement a single node, simple node, that will give you a lot of confidence. Take a proper data set and implement this. Okay. Thank you. Best of luck, Aditya.
Thank you, sir.
Yeah, Mukesh, sir, you can invite the other con.
Yeah, thank you, sir. Next, I am inviting next researcher, Kamal Jyoti Talukdar, for their paper presentation.
Hello, am I audible?
Yeah, you're audible, Kamal.
Hello, am I audible?
Yes, you are
Yeah.
audible.
Yes.
Okay, let me share the screen, sir.
Okay.
One minute, sir. Is it coming, sir?
Yeah, Taluk, it's just coming, Kamal. You can proceed.
1 minute, sir. Okay. Good morning, everyone. So I am going to present a research paper titled Modeling of Water Distillation Unit Operated by Solar Photovoltaic Modules. So what happens? Basically, for water purification and water distillation, heat energy is needed, and this heat energy can be obtained by burning fuels or electric heating. Different people in all over the world have used different techniques to do water distillation and water purification. So these are explained in references from 1 to 6. So I am not going into details what other people have done. Let me confine to this my work. So this is the brief system layout of water distillation unit. The figure I have taken from reference number 7. So what we can see in this figure, the left hand side centrifugal pump is there. So what happens through the centrifugal pump, water at ambient temperature is pumped through this inlet pipe, and it goes through this particular loop. So when it goes through this particular loop, what happens? It absorbs the heat coming from the steam from the vaporization chamber, and this water is converted into heated water up to 50 degrees centigrade. So once it is heated to 50 degrees centigrade, it is collected in the vaporization chamber. And what happens in vaporization chamber, heating element is there. So by using this heating element, steam is produced at a temperature of about 100 degrees centigrade, and the heating element is heated in such a way that per second we get 10 kg of steam at a time. So once the 10 kg of steam is passing through this loop, it goes through this pipeline. Then what happens? It goes through this loop, and it rejects the some amount of heat to the water coming from the inlet to 50 degrees centigrade. That means I want to say that the steam at 100 degrees centigrade is converted into 50 degree centigrade water, and it is collected here as distilled water. Now coming to next figures. Figure number 2 shows the schematic of solar photovoltaic system during sufficient radiation and daytime. So during daytime, what happens? Solar radiation falls on photovoltaic modules, and current IPP is generated. Now it is passed to surge controller. What happens in surge controller? The excess current after meeting the requirement of pump and heating element is sent to the rechargeable battery for the storage during nighttime or solar deficient hours. And during nighttime, what happens? The current produced by photovoltaic modules is almost nil. So the charge stored in rechargeable battery during daytime is used by this pump and heating element. And one thing we should know, that this electric energy needed for running this pump and heating element is obtained from solar photovoltaic modules. Now coming to the modeling of water distillation system. So equation number 1 shows the current produced by photovoltaic module. So this IPP is equal to IL minus ID, where IL is the light current and ID is the diode current produced by photovoltaic cell. Equation number 2 shows the amount of heating needed by the heating element, which is QPP. It is given by MW into CP into 373 minus 323.15 plus MW into L VAP. So what is the meaning? MW is the mass of steam produced, which is considered 10 kg per second. CP is the specific heat of water. 373.15 is the temperature of 100 degrees centigrade, and this is 323 means 50 degrees centigrade. And next heat is converted into latent heat of vaporization by heating through heating element. Now equation number 3 shows mass flow rate of water that is sent through the inlet pipe for heating to 50 degrees centigrade. So this QPP already I have discussed in equation number 2, and then denominator we get CP into 323 minus 2F. That means 50 degree minus TF. What is TF? TF is the temperature of water at ambient temperature. In January, this means the temperature is less. So I have considered 22 degrees centigrade, and in May it is a hot month. So temperature I have considered to be 28 degrees centigrade. Now equation number 4 shows the volume flow rate for the water inlet. Equation number 5 shows the current required by heating element. So these are the resistance I have considered to be 200 ohm and 0.85 is the power factor. Equation number 6 shows the current required by heating element, and this is the equation. And equation number 7 gives the pumping power required during the daytime. And equation number 8 shows the current required by pump. And lastly, equation number 9 gives the number of photovoltaic modules needed in series. And equation number 10 gives the total current required by solar photovoltaic modules in 1 day. And these are the assumptions. Hello, am I audible?
Yes, sir. Yes, you are audible.
And equation number 11 shows the number of photovoltaic modules needed in parallel. Now coming to the results and discussion. So from equation 2, what we see, the heating load by heating element obtained for both January and May is obtained as 24670 kilowatt. And MW, that is mass flow rate of steam, obtained at 100 degrees converted into water at 50 degrees centigrade by rejecting the heat of mass flow rate of steam to MW1 untreated water pumped by centrifugal pump by increasing the temperature of MW1 from 22 in January to and 28 degrees centigrade in May to 50 degrees centigrade. Now this MW1 water is obtained from equation number 3 and it is found to be 209.778 kg per second for January and 266.991 kg per second in May. And it is seen that MW1 is more in May due to the fact that TF is more in May. Hence the term 323 minus TF term in denominator decreases, leading to more amount of MW1. And volume flow rate we have calculated and it is found to be 2.209 meter cube per second in January and 0.266 meter cube per second. And the current required for heating element is obtained from equation number 5 and 6. And pumping power of centrifugal pump is obtained from equation number 7 and found to be 20.9 kilowatt in January and 26.6 kilowatt in May. And the value of WP in May is more due to more PW1 in May. The current required by pump IP3 in January is 669.613 ampere and 852.236 ampere in May. IP3 is more in May due to more amount of WP in May. And what we see, the system voltage is considered to be 48 volt, and if we use the particular equation, we get two photovoltaic modules that is needed in series of Central Electronics Limited PM150. This Central Electronics Limited PM150 is the type of photovoltaic module which is manufactured by company. And the current SPB required from photovoltaic modules in a day is obtained from equation number 10. And we have calculated it for January and it is found to be 5635.870 ampere by equation 11. And it is found to be 1174 photovoltaic modules in parallel of Central Electronics Limited PM150. And we have calculated it for January because in January the solar radiation is minimum, and if it works well in January, then the whole system will work well throughout the year. Now figure shows, figure number 4 shows battery charging and discharging pattern in January, and figure 5 shows battery charging and discharging pattern in May. So what we see, the battery discharging pattern is constant since the QPV and pumping power is constant throughout the day. And we see from 6 hours to 18 hours the charging pattern shows this way. So why it happens? Because from 6 hours to 12 hours solar radiation increases, and again from 12 hours to 18 hours solar radiation decreases. As a result, this pattern of current is, this pattern of charging is seen. And similarly is the case for the month of May. And what we see, the cumulative battery discharging and charging
Jyoti,
for
please conclude, beta.
Okay, so
yeah.
Cumulative battery charging and charging for January and May is obtained in this way, and battery capacity required is this much. So finally, conclusion, we can say that for this particular case study, 3038.948 ampere hour and 22317.891 ampere hour and 3535.44 ampere hour and 35662.87 ampere hour respectively is the cumulative battery charging and discharging for the month of January and May. And for this case also 1174 modules in parallel is sufficient to work throughout the year. So these are my references. Thank you.
Kamal Jyoti, is location also a factor in this?
Yes, sir. I have taken consider the location to be Kolkata city.
Okay, so if I shift this distillation plant to somewhere in Delhi, will it affect your calculations?
Yes, sir. It will affect because the solar radiation will be different in Delhi compared to Kolkata.
Okay, so in Calcutta, these are very popular, I suppose, distillation plants and all,
Yes, sir.
because of your factors that you have listed.
Yes, sir.
Okay, so have you also used any software tool for this?
Yes, sir. Means actually I have coded these equations in C language, and based on the simulation, I have obtained these results and
Okay.
plotted here.
Okay, because I thought data was from that company from where you're doing. So you have done that in C. Good.
Yes, sir.
Okay, thank you, Karam.
Thank you,
Any
sir.
audience, if anyone has any question, the audience can ask the question. Otherwise, let's move to the other candidate. Yes, Mukesh, so we can move to the other candidates now.
Okay, sir. Okay, for the next presentation, we are inviting Umet Yuba for their presentation. So now we are handing over the mic to Umet Yuba for the presentation.
Hello? Am I audible?
Yes.
You're audible.
Okay, let me just share my screen.
Yeah, sure.
Can you see the presentation now?
Yeah, I can see and I can listen also. Please
Yeah.
proceed.
Okay. Good afternoon, everyone. My name is Umet Uba, and I'm a research scholar in Department of Mathematics in Aligarh Muslim University, and I'm currently working under the supervision of Dr. Wakil Ahmed Khan. The paper that I'll be presenting today is entitled New Convergence of Sequences of Fuzzy Star-Shaped Numbers, which is defined using the LP metric. I'll walk you through a historical background, and then we'll go to the definitions, and then proceeding with my main results. So in 1965, as you all know, Zadeh expanded the concept of a crisp, or we usually call it as a usual set, to a fuzzy set. The motivation behind it was that not everything in life is just black or white, or in mathematical terms, 0 or 1. There has to be a gray area in between 0 and 1. And hence, he generalized this concept of characterization function of a crisp set to a membership function of a fuzzy set. The first definition that you see on the screen is that of a membership function, which is defined for a fuzzy set A on the universe of discourse X, and is defined from which whose domain is X, and all the elements of these set X gets mapped to the numbers between 0 and 1. So, and in contrast to what happens in a crisp set, where if an element belongs to the set, the value of the characteristic function is taken to be 1, and if it is not in the set, it's taken to be 0. Here, Zadeh generalize it at saying like, why just does it have to be just 1 and 0, and instead took the value between 0 and 1. So, crisp set has a unique membership function, and for a particular set, it coincides with the characteristic function. Now, after the introduction of fuzzy set, Matloka, an author and scientist, he generalized this real number to fuzzy number in such a fashion that it retained the properties of real numbers in terms of its membership functions. Later on, several authors studied these fuzzy numbers and defined the arithmetic on it. And later on, again, it was generalized to fuzzy star-shaped number. So basically my work here is on a fuzzy star-shaped number, which is whose characterization function or a membership function is a function which is defined from the Euclidean space Rn 201, which satisfies the conditions such that the function is normal. That is, there exists at least one point in the domain for which the function takes the maximum value to be 1. Condition of continuity was also relaxed, and here the function is taken to be upper semi-continuous. The support of the function is said to be compact. And again, use fuzzy star shape with respect to a point belonging to the domain, such that for all the elements, other elements belonging to the domain, and lambda restricted to 0, 1, this condition, which is marked by equation 1.1, is satisfied. So mu of lambda s plus 1 minus lambda t is greater than or equal to membership value of a function of all the other rest of the points. So in this paper, wherever you see Sn, that is the collection of all fuzzy star-shaped numbers, and by omega star Sn, we denote the set of all sequences of fuzzy star-shaped numbers. The next thing that I've defined is for any fuzzy star-shaped number belonging to Sn, its alpha level set is given as collection of all those points in the Euclidean plane for which the value of the function at that point is greater than or equal to alpha, and alpha has to be restricted to 0 and 1. This is when alpha belongs to open interval 0 and close interval 1. And it becomes complete support if alpha is equal to 0. Now, after defining the fuzzy star shaped number, we try and give it a certain structure, because until and unless a set has certain structure, you cannot proceed further, to define a linear space, a vector space, or a norm space. So that helped, that was done with the help of alpha level set, and hence the characterization of fuzzy number or fuzzy star shaped number is usually done with the help of alpha level set. Now, the linear structure of all these star shaped fuzzy numbers also induces in scalar addition, scalar multiplication and addition. So as long as you have this scalar multiplication and addition, you can define it as a vector space. If it's a vector space, you can obviously define a norm and proceed to a metric, and then again topology can be defined on it. Moving further, we generalize the definition of fuzzy star-shaped number. So we take a sequence belonging to omega star Sn. We say that it is convergent to another fuzzy star-shaped number u naught if there exists any positive integer, such that the distance with respect to the LP metric between that fuzzy star-shaped number and the point to it which converges is less than epsilon after certain terms. And we can also write it in a different pattern, saying limit k tends to infinity, distance between uk and u naught tends to 0. After that, as considering the metric space SNDV, we define an open ball which is centered at the fuzzy star-shaped number u and with a certain radius r. It is collection of all those fuzzy star-shaped numbers for which the distance, again with the LP metric, between those two fuzzy star-shaped numbers is less than r. Continuing further, we define a non-empty subset U. It is said to be open if for all the fuzzy star-shaped number there exists some radius greater than 0, obviously, for which the ball centered around those is contained in that set U. Uh, then we define the boundedness of a sequence. We took a sequence, so we have to talk about its convergence and boundedness of it. So sequence U is equals to UK belonging to omega star Sn is said to be bounded if we find any positive integer such that dp, that is the distance between all the terms of the fuzzy star shaped number, and 0 bar, which is the identity identity in that space, is less than equal to m for all k belonging to n, or if the set of all the terms is bounded. Then we define the Cauchy convergence of the sequence, which is a sequence U is equal to UK. Is said to be Cauchy sequence if for every epsilon greater than 0, there exists some positive integer for which the distance between any two terms of fuzzy star-shaped number is less than epsilon. Here, the metric that we have used is given below, written there. The LP metric, I've given the reference also, for which 1 less than equal to p is less than infinity is defined as dp of uv is integration from 0 to 1 where dh, and dh here is the Hausdorff metric, the distance between the alpha level set of fuzzy star-shaped number of one set and the alpha level set of another fuzzy star-shaped number. So this is our metric that we have used in the paper, and the space that we have considered is the space of all fuzzy star-shaped number. So we can see the real number can be embedded in fuzzy numbers. So the space of all fuzzy numbers as any m belong to Rn can be viewed by the following. Then it is obvious that m bar belongs to Fn. Here Fn is the space of all fuzzy number for which any m belongs to Rn. After the introduction of fuzzy number, Matloka introduced the bounded and convergent sequences of fuzzy numbers and then studied some of its algebraic and topological properties of it. Then sequences of fuzzy numbers have also discussed by different authors which have mentioned, and moving further, topological properties of these fuzzy numbers have been studied. So basically in fuzzy number, there was a condition for which the membership function, the characterization was done in terms of membership function and whose set was convex. This condition of convexity was relaxed in fuzzy star-shaped number, And here in this paper, we've defined sequence spaces of fuzzy star-shaped numbers using this LP metric. So following three spaces that you see on your screen are these spaces of fuzzy star-shaped sequences, where C naught Sn is the all collection of all those fuzzy star shapes numbers, which converges to 0 in that space. CSN is the sequence space in which the collection of all fuzzy star-shaped numbers which converges to a point different to 0, that is some other fuzzy star-shaped number, say u naught. L infinity Sn is the space of all fuzzy star-shaped numbers which is bounded. And these are the main results that we have studied in this theorem, in this paper, sorry. The space of all fuzzy star-shaped numbers, which is denoted by Sn with respect to LP metric, is a Hausdorff metric space. And since we've talked about the convergence of the sequence, any sequence that fuzzy star-shaped sequence that converges in the space obviously has a unique limit. Now, a convergent sequence of fuzzy star-shaped number is bounded. We know that every convergent sequence is bounded. We proved the similar result that this happens the same for a fuzzy star-shaped sequence too. But the converse is not always true. We provided certain examples also. This shows that the inclusion is strict. That means every fuzzy star-shaped number, if it is convergent, it is bounded, but the converse is not true, which means that every bounded sequence may not be convergent. Now, every ball in the metric space SNDP is an open set. Moving on to the next theorem, if any fuzzy star-shaped number is convergent to a fuzzy star-shaped number u naught, then any subsequence of the sequence will also be convergent to the same limit. If DH is any in translation invariant metric, then the sequence spaces that we have defined above are linear spaces over the field R. And the space that we've defined for the bounded sequences of fuzzy star-shaped number is also a complete metric space with respect to the metric defined as supremum taken over K, dp of uk and vk. The next theorem we prove that the intersection of all those CSN and L infinity Sn is a closed subset of the complete metric space. And moving to the last and final theorem, the intersection space that we have defined is nowhere dense in the complete metric space. These are the references that I've used. That's it.
Yeah, have you published any paper before this also?
No, this was my first paper. It's currently under process.
So can you tell me where this research that you're doing, where will it be applicable in real life?
Yeah, I was thinking about the same, like because this conference is mostly based on the application part, and we
Yeah.
usually work on the theoretical part. So the only thing that I could come up with was because for every application applied part that you do, you need a theoretical base for it. So it's our work to develop the theory, and right now I don't have any practical use that I can tell you of, but maybe in future you might be able to use it.
You are in first year or second year of research?
Yeah, December I'll be finishing my third year.
Okay.
Yeah.
So you have 2 years left there.
Yes, sir.
The standard of research is quite high. So that's where
Yeah.
you'll have to pull up the socks. Okay.
Yeah,
Thank you
sir.
so much, Ome.
Yeah,
Thank you.
thank you, sir.
Okay, for the next presentation, we are inviting Mr. Mehtab Alam for their presentation.
Hello.
You're audible
Hi.
now.
Okay, I think there was some problem with my earphones.
You're audible now. Please proceed.
Okay, sir. So first of all, good morning, everyone. And once again, I am presenting Mehtab Alam's paper, and it is about IoT and AI for smart and sustainable agriculture. first of all, I would like to talk something about it. And as we all are aware with this, that in world rising population leads to many problems. If we only talk about India, so there's a shortage of food is a major problem with the rise in population. And being an agricultural country, growth in agriculture, smart agriculture with the help of latest technologies would be a better solution for the same. So here we'll see how information and communication technology and other technologies will help to solve this problem, providing growth in agriculture to maintain sustainable development. Uh, and if we see recent developments like specialized robots, drones, and an important area that is big data, and also blockchain technology, which are and exactly it is playing an important role in providing tools and technologies to farmers in order to increase the production and maintain a sustainable agriculture.
Your slides are not moving, beta.
Oh, sir, I'm
Please run this presentation.
okay. So uh, till now we have a rough idea about what this paper actually focuses on. And the biggest source of income in India for farmers is agricultural source. And if we talk about green revolution 60s, we have come from far, as India is under top 15 exporters of agricultural products in the world right now, along with New Zealand, Australia, and Japan. And as it is one of the main sector to fulfill food requirements in India, it needs to be advanced by the help of smart technology like AI, IoT, and what we have used in this blockchain technology. So I will talk about blockchain in this paper later on. And blockchain basically has a powerful impact on agricultural businesses. It is to join interlink the data. What are the benefits we will see we will see later on. Coming to the problem statement, so in this paper the main focus is a small district that is Badaयूं in Uttar Pradesh, where the smart technologies, AI, IoT, and blockchain technologies have been used to see the results, how they are benefiting the agricultural state of the Badaयूं. A lot has been done to improve cultivation, but Indian agriculture depends upon traditional farming technique and natural water irrigation. Farmer usually depends on natural water irrigation or from water from the rain-fed areas. So farmers rely on underground water, and so due to overpumping and in many areas groundwater level falls. Problems like salty soil arises due to this, and floods and soil disintegration. Also there is a another difficulties as well, like presence of brokers in the chain of agricultural business, due to which farmers don't get the price they deserve for their product, and also no access to high quality pesticides, and farmers are not much aware with the information to comprehend the soil as well. So the main question arises, remember we are focusing Badaयूं, it is small district in the Uttar Pradesh. So what are the needs of the farmers, especially in Badaयूं, on which we are mainly focused? And second one is, by using which technology and how can we add it to achieve sustainable agriculture to also improve total profit for the farmers. So what is the current state of agriculture in Badaयूं? There is the rainfall period is from June to October, and temperature rises from 4.5 degrees Celsius to 45.4 degrees Celsius. And among agricultural crops like wheat, mustard, potato, sugarcane, baja, etc., we have focused on sugarcane, rice, and wheat in the selected town Badaयूं. If we talk about production and cost so far, so here is rice. It is 3 quintals per biga. Rice we have 3 quintals per biga at the cost of 3,000 per quintal, and for wheat it is 4 quintals per biga at cost of 1800 per quintal, and for sugarcane it is 50 to 60 quintals per biga at cost of 325 per quintal. Uh, as we discussed earlier, small cities have their own problems, especially a small district. Farmers have low yield and usually don't get profits they deserve. So with artificial intelligence and IoT, things can be changed, and actually things are changing with the blockchain as well, coupled with these technology. So it is again helping and achieving great growth in the yield. So how AI, IoT, and blockchain are working in this? So I would like to give a short talk about something IoT, and it's a network. It is basically a network of physical objects that are embedded with sensors, and which makes exchange of data and connection with other devices and systems over internet easier. So it can be used for gathering data to gain correctness in information, and also to develop new business models. Here are a few examples, like it can be used for crop monitoring by the farmers and analyzing production quality of the crop, and data collection with the help of installed sensors, like when they can know the weather condition. So they will reduce the risk. It can reduce the risk, and because this data with this data, farmers can better analyze the future situations, and so they can make better decisions. And for AI, coming to AI, predicting behavior of AI is far better than human mind. In agriculture, it helps a farmer to draw insights from the data collected,
Better move
such as
slightly forward. We have already read this now. Move forward.
Okay, sir. So what are the different benefits of using these technologies in the agricultural field? So collaboration of blockchain into agriculture aims to provide mobile-based services, which will assist farmers in analyzing and monitoring the information, like financial transactions from inputs. First one is traceability. So blockchain technology will give a clear picture of trending prices and help in increasing the income of farmers, and hence skip the dealing with the intermediaries, brokers, which causes a major problem in the agricultural business chain. So, second one, we have registration of land. It's here I am having a good example. Andhra Pradesh government has recently collaborated with Cromaway, which is a Swedish company, for the development of a blockchain based platform through which record keeping of land registration can be conducted. Last one, we have food security. So it will detect any fraud from the uh, till the food reaches to the final customers from the farm. Uh, Blockchain will help them to keep track of information transactions occurring at each level. Here we can see the results. Uh, uh, this is the data of wheat and rice production for years from 1997 to 2019 for district Badaयूं for smart agriculture and going technological innovations. And this data is taken from OGD, Open Government Data Platform, which is under Government of India. So here we can see a clear exceptional hike in the in the production of wheat in the year 2019. So here also in the production of okay sir. Here also in the production of rice, it rises from -4% in 2017 to 16% in 2018 to 2019. This is the growth of the production in wheat, and it is for rice. So coming to the conclusion, blockchain playing a a very vital role in smart agriculture, and being a growing technology with other technologies can improve the agricultural growth and also helps farmers to be at safer side by predicting climate accuracy, and they can decrease the water use also, which is a big problem in itself, and hence raises their total profit. So many different technologies like drones, robots, data analytics, they are all helping farmers to improve production. As we have seen the data, it's clearly showing that use of these technologies with blockchain have increased the crop output per yield since 2019 onward. So it's showing exceptionally well results, especially in the Badayu, which we have mainly focused on. Thank you so much.
Okay, how do you foresee the future for this smart agriculture, Vita, if you have gone
Yes,
through
sir.
this? Yeah. How would the future look like?
Sir, as we are talking about mainly AI in IoT in the agricultural field, so the I will like to give an example. Agricultural drone, which we are using right now in many states of India. So it will what it will do is it will monitor the crop health quality and automatically give the what are the requirements of the crop. So right now we are not using it on a very higher scale, but in the future I think there will be a great scenario where we will see technology in the agriculture and will make it even smarter from right now.
Thank you, Mehtab. You know, we had a locust attack 2 months back,
Yes, sir.
and that locust attack was countered by the use of drones, by the use of AI.
Yes, sir. Yes.
So this technology is picking up. A good paper, and thank you very much. If any audience has any query from the researcher, the audience can ask the question. You can type in the chat box also. From my side, thank you. Yeah, Gurpreet sir, good morning.
Very good morning,
Gurpreet
sir.
sir.
Very
How are
good
you?
morning, sir.
How are you?
Fine, sir, fine. What about you, sir?
I'm fine, perfect. And it's been a wonderful session.
Okay, sir. Thank you, sir. Thank you very much, sir.
Dr. Mukesh has been with us since morning,
Yes,
and
sir.
we have
Yes,
been
sir.
having a very good time here.
Yes, sir.
So
Sir,
I would congratulate you for this conference. This is a wonderful conference, wonderful
Thank you,
of
sir. Thank you
papers,
very
and
much.
thank
3
you.
days.
Thank you again, sir. Thank you.
And 3
Thank
days
you.
is a very big period. 3 days is a long period. And
Uh,
hold it successfully. It's a very good
from
effort.
Sir, we are also thankful to you. You are with us from last 2 days.
Yeah, yeah.
So
So
very thankful to you.
should I say something to the participants?
Yes, sir. Definitely, sir.
Yeah, so thank you very much, participants, for presenting your papers. The paper on cryptographic solution was a wonderful paper. Cryptography is the need of the hour. We need to have secure systems now, and security has never been so vital. In COVID times, we have been hacked, we are being hacked, and in future also we'll be hacked. So for cybersecurity and all, we need
Thank
to
you, sir.
have this
Thank you very much.
cryptography. We need to have it. So wonderful paper. Water distillation paper was also very good. Kamal Jyoti, you have worked wonderfully on this. Please try and apply it on some other data also, some other location also, and come up with a solution. The fuzzy star solution, the paper from Ume was very good. And I wish best of luck to her for the future research. Then the smart agriculture put up by Adnan in place of Mehtab, because Mehtab was not there because of internet connectivity. So on all, this session has been wonderful, and I was the first one to start it with my invited talk. The talk was on agile computing, and it was wonderful to interact with you all. And it's always wonderful to interact with people sitting far away. So it's always been my dream to visit Punjab, to visit Batinda. As I said yesterday also, I like Sufi saint, which is Baba Farid. I've been a disciple also. So wanted to visit, but then COVID has stopped it. But next time, inshallah, we'll be visiting on the conference. I'll definitely be visiting your campus. And
Sir, it
special
will be
thanks to
it will be great pleasure for us to if you visit in Bathinda at Baba Farid Group of Institutions.
yeah.
We
Thank
are
you so much, Mukesh
inviting
sir. Yeah,
you at Baba
surely
Farid
I'll
Group of
visit.
Institutions.
Yeah, I'll visit surely. And please pass on my thanks and gratitude to all the members of this conference, the team, and the Professor Meher Chand. Please
Yes, sure,
pass on
sir.
my information to him. Thank you, participants. Been wonderful interacting with you. Please do join the valedictory session. It will give you a lot of confidence for the future. So thank you, everyone.
Thank you, sir. Thanks a lot. It's really a very wonderful talk in this session. So now I would like to invite engineer Gurpreet Singh for thanks to our chairperson, Dr. Raja Khan, sir, and all the participants who present their papers and participate in this session on behalf of. So now I would like to invite Mr. Gurpreet Singh to thanks to all the delegates on behalf of Baba Free Group of Institutions. Sir.
Thank you, Mukesh, sir. So, first of all, respected Ithiram Raja Khan, we are very thankful to you be a part of this session, and you are part of this conference from last 2 days. And dear participants, we are very thankful on the behalf of Baba Farid College. We would like to thankful. We would like to thank to all of you, and along with that, I invite you all in the next session that is running parallel in this session. So valedictory will be there. So dear respected Ithiram sir and
I'll be
all
there,
the
sir.
participants kindly join that session. So we will carry in that session, sir.
Okay, sir. Thank you so much. We're joining there.
Thank you to all of you. Thank you, sir. Thank you very much, Rajakant sir. Thank you very
Okay,
much,
sir.
sir.
Okay, sir.
Okay, sir.